So in this video, I'm going to go over natural logarithms, and continuous compounding interest. So first, I want to answer the question, what is a natural base E? It's the number 2.7182882. E is it's an irrational number whose value is known, and it's kind of like pi, okay? So when we look at, if we were to graph e to the x power, it would look like this. And so obviously at 1, we would have e to the first, right? So that would be this number up here. So natural exponential functions, or exponential functions with e as the base, they have the same properties as functions you have studied. So the graphs of exponential functions, such as f of x equals 3 to the x power. So the domain, as you can notice here, the domain is all real numbers because it's going left and it's going right, and it's going to continue to do so. Whereas the range is going to be y is greater than 0, because it's going to approach that asymptote y equals 0, but it will never reach it. So some examples here of when we evaluate f of x equals e to the x power with the following values of x. So what we're going to do is we're going to do f of 2, which would mean that we're going to take e to the second power. So go ahead and get your calculator out and do that now. So I'm going to take you guys to the TI-84, maybe, and show you guys this here. So second, I'm going to go down here to ln, that's e to the x. And I'm going to show you this to the first power. To the second power, sorry. And then we're going to push enter, and see that gets us our value here. And we're just going to round this to the nearest tenth. So this is going to be 7.4 because that 8 would round this up to the 4. Okay. Now I also want to show y'all in decimals. Let's see if I can get there. So here again, if I just type in e here, y'all, and I take that to the second degree e, and then again we'll just take it to the second right there. Notice again, same number, okay? 2 ways to find it. So this is 7.4. Now I'd like you guys to do the other 2, okay? So again, this is going to be f to the 1/2. So you're going to do e to the 1/2 power. And when you do that, you're going to get 1.6. And this one's going to be f of the -1. So that's going to be e to the -1. And when you do that, you're going to get 0.4. Okay? So that's just practicing taking e to a power. So now we're also going to talk about the natural logarithm. Okay? And that's your ln on your calculator. And what we had to do to get to e was do second ln. So a logarithm with a base of e is called the natural logarithm, right? And it's abbreviated as ln rather than log base e. Natural logarithms have the same properties as log base 10 and logarithms with other bases. So the natural logarithmic function f of x equal to ln of x is the inverse of the natural exponential function f of x equals e to the x, okay? So y equals log base e of x is written instead as y is equal to ln of x, okay? So these are inverses of each other. So y is equal to e to the x is an inverse of y is equal to ln of x. So if we were to graph these again, if we were to graph e to the x right here, the domain of that one is going to be what we said before, right? So our domain was all real numbers, and then remember y was greater than 0. So obviously when we talk about the ln of x, that's what this one down here is. Let me move this out of the way so you guys can see it. So the red one down here is ln of x, right? So when we do this, notice again that this is our asymptote, and now is the y-axis. So that's why our domain is going to be f of x equal to ln of x, that of x is greater than 0, right? Because that is our asymptote, and it's never going to reach that. And then the range, notice this graph's going down and it's going up, 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 right? So our range is going to be all real numbers, okay? So now we're going to do some of these in the calculator, same way we did the last one, okay? So I'm going to take you guys out there. So we're going to do the ln this time. So basically, let me do it this way. We're going to do f of 2 here. So that's going to be the ln of 2, okay? So let's go back out here to these two functions and see how we do it. So in your graphing calculator, you just go the ln of 2 and push enter. Well, let's close that parenthesis. Wait, where's enter? enter there. Okay, sorry. So this one, again, on this one, we're going to write it to 2 decimal places, right? So to the 100th, okay? So we're going to put 0.69. And with decimals, again, same thing. We can do ln of 2, and it gives us the value right there, again, 0.69, okay? So we're going to go 0.69 here. Then I'd like you guys to go ahead and do the ln of 1/2 and the ln of -1, okay? So we're going to do f of 1/2 here. So that's going to be the ln of 1/2. And you're also going to do f of -1 here. And so I want you to do the ln of -1, okay? So when you guys did the ln of 1/2, you should have got -0.69, right? So it's a negative that time. And now when you do the ln of -1, you're going to get an error message, right? So you got an error message, or it said undefined, one of the two. And that's because you can't take the log of a negative number, right? Can't take log. What's going on with my pen? Can't take the log of a negative number, okay? That's why. Anytime you do the ln, or the natural log, anytime you take the natural log of a negative number, is going to give you an error message, okay? All right, so now we're going to go on to talking about the fact that we know that ln and e are inverses of each other. That's your first blank there. So when they are next to each other, they basically cancel each other out, okay? So when we're doing these types of problems, if we have an ln and an e next to each other, then our answer is going to be what comes next, right? So right there, they cancel each other out. Here again, we have e to the ln power. So this is going to be x plus 1. And here, ln of e again are right next to each other. So this is going to be 2x. And here again, they're next to each other. So this is going to be plus x. So then we're just simplifying 2x plus x, and that would be 3x. So go ahead and do these U-tries down below and see if you guys can give me the correct answers. Okay, on these, again, cancels out. So this is just 25x. These two cancel each other out, so you're just left with x plus 2. And these two cancel each other out, so you have 4x here. And then you have plus 2x plus 1. So these are like terms, so that's going to give us 6x plus 1. It is that easy. Yes, guys. Okay. So now that we know that we can put them next to each other to cancel one another out, that's exactly what we're going to do next. So we're going to use what we just saw to simplify. So we're going to put an e here, and we're going to put an e here. So we're going to take e to the ln. So now what happens to these? They cancel each other out, right? So we're left with x plus 4, and then e to the 9th power is going to be 8,103.08. So to continue this, we're going to subtract 4 from both sides, right? So that's going to give us x is equal to 8,099.08. So go ahead and do the U-try below. Same process, right? So go ahead and do the 4a below here, and we're going to go to the right after you guys work each of these, okay? So what do you think we're going to do here? Again, yep, take this to the e power, take that to the e power, right? So e to the 2nd is going to be 7.39. And then these cancel each other out, right? So that's going to be equals x plus 3. So we're going to, again, subtract 3 from both sides. Right? So that's going to be 4.39. That's going to be equal to x, okay? All right, so we're going to do our next one here. So this time we're going to do ln of e. So we're going to put an ln in front of here, and we're going to put an ln in front of here. Because again, that's going to enable us to cancel out what comes next. So that means these cancel out. Okay, so that's going to give us the 1/2 x minus 5, and then we're going to take the ln of that number, 725,954. That's going to give us 13.5. Now this is just a simple algebraic problem, right? So we're going to add 5 to both sides. Oops, I keep putting that in the wrong place, sorry. plus 5 here. So that's going to give us 1/2 x equals, it's lagging, y'all, sorry, 18.5. And then to get rid of a 1/2, we multiply by its reciprocal, right? So we're going to multiply both sides here by 2 and both sides here by 2. So our x is going to be equal to 37. Okay? All right, go ahead and do the one down below, the 4b, and then come back to me and we will work it together. All right, so we're going to do ln here again and ln here. Okay? So the ln and the e, again, cancel one another out, right? So we're left with x plus 33. And then we're taking the ln of 6 in our calculator. And when we do that, we're going to get 3.5. So now we're going to subtract that 33 from both sides, right? So now it's gone from there. So this is x is equal to negative 29.5. Okay? All right, got one more we're going to do together up here. So again, this time ln and e are already next to each other. Do you notice that? So as a result of that, they cancel each other out. So we got x to the 8th is equal to 65,536. Now how do we get rid of an 8th power? You got it. We take it to the 1/8. So we're going to take both sides to the 1/8 power. So when we take 65,536 to the 1/8 power, we get that x is equal to 4. And you can test that by doing 4 to the 8th and making sure that it's 65,536. Okay? So go ahead and do this 4c down here, and then come back to me when you're done. So here again, these guys cancel each other out, right? These two cancel each other out, so we have x to the 5th is equal to 7,776. So we're going to take this again to the 1/5 power. And when we take 7,776 to the 1/5 power, we get that x is equal to what? 6. So in this next set of problems, see that it says find the inverse. So the first thing we're going to do, as we did before with inverses, is swap the x and y. So we're going to say the ln of y minus 4 is equal to x. That's going to be our first step. Now we're going to take these to the power, right? So we're going to take this to the e power, and we're going to take this to the e power, right? So that's going to be, these are going to cancel each other out. So we're going to have y minus 4 is equal to e to the x power. And we're going to solve for y, so we're going to add 4 to both sides. So it's going to be y is equal to e to the x plus 4. That's the inverse, okay? So go ahead down here on the bottom, do the 5a for me. Okay, here again, we're going to say x is equal to the ln of y minus 6, right? Okay, so again, we're going to take this to the e power. We're going to take this to the e power because that's what's going to get rid of our ln. So we have e to the x is equal to y minus 6. So this time we're going to add 6 to both sides, right? So this is going to be e to the x plus 6 is equal to y. So on this next one, I'm going to create this, make this a y, okay? Then I'm going to go in and once again swap the x and y. So x is equal to e to the y plus 6 plus 2. So I'm going to go ahead and subtract that 2 from both sides. So I get x minus 2 is equal to e to the y plus 6. Okay, so I'm going to use my ln to get rid of the e and write the inverse, right? So, sorry, ln, I can't write apparently today. So, ln of x minus 2. Okay, so now this cancels out that. The ln cancels out the e, right? So we got ln of x minus 2 is equal to y plus 6. So we're going to subtract 6 from both sides. So this is going to be ln of x minus 2 minus 6, and that's going to be y. So that's my inverse there, okay? So now go ahead down below and do the next inverse for me, if you would. So once again, this is y, so we're going to make that x as we swap our x and y. Y minus 3 plus 4, so aren't we going to subtract 4 from both sides? So that's going to be x minus 4 is equal to e to the y minus 3. So once again, we're going to take ln of both sides so that we can do the inverse. Those cancel each other out. So we have ln of x minus 4 equals y minus 3. So aren't we going to add 3 to both sides? Yes, we are. So this is going to be ln of x minus 4 plus 3. That equals our y. Okay? All right, we're going to go up here and do this last one together, and this one's going to be a little more complicated. So once again, we're going to say x equals 2 ln of y minus 5 minus 3. So the first step we're going to do here is get everything but the ln, okay? So we're going to add 3 to both sides. So that's going to give us x plus 3 equals 2 times our ln of y minus 5. Now what we're going to do is, this 2 is being multiplied, so we're going to divide by 2, okay? So that means we're going to divide this right side by 2 and the left side by 2, right? So now that gives us x plus 3 over 2 equals our ln of our y minus 5. So again, how do we get rid of the ln? We take it to the e power, right? So we're going to take both of these, e's to the e power. So that's going to give me, then these cancel out, right? So then we're just left with the y minus 5 over there on the right. So we're then going to add 5 to both sides. So this is going to end up being e to the x plus 3 divided by 2 power. Wow, that's not very legible. Let me see if I can clean that up a little bit, y'all. This thing is really struggling. I think I got too much written on the screen. Divided by 2, okay, and then that is going to be plus our 5, and that's going to be equal to our y, okay? Okay, so let's see if you guys can do this last one. Do it on your own and then come back to me when you're done. All right, on this one again, we're going to rewrite, say x equals 3 ln of y minus 4 minus 2. So we're going to add 2 to both sides. So that's going to be x plus 2 equals 3 times ln of y minus 4. And again, we got to get ln and what comes after it all by itself. Okay, so we're going to divide by 3 on both sides here. So that's going to give us, now that's gone. So now how do we get rid of the ln? We take it to the e power, right? So this is going to be equal to ln of y minus 4. So now we're going to use our e over here. So we're going to do e here, and we're going to do e here. Remember, this is now a power, right? So those cancel each other out. Let me scroll down so I have a little more space. So this is going to be e to the x plus 2 over 3 power equals y minus 4. So we're going to then add 4 to both sides, aren't we? So we're going to do plus 4 here and plus 4 over here. So our final answer will be, let's move this out of the way, e to the x plus 2 over 3 power plus 4. That's going to equal our y. So that is our inverse function there. Okay? All right, now we're going to talk about continuously compounding interest, okay? So with continuous compounding interest, we have our amount that we're going to get after the fact. We have our principal. That's the money we start with. We're going to use e. Yes, the e that's in our calculator to do this. And we're going to multiply, or we're going to take that to the power of our rate of interest times our time, keeping in mind that we're always going to turn this into a decimal. So if it was 6%, it's going to be 0.06. or whatever it is. We're going to move the decimal plate. We're going to move the decimal 2 places to the left or divide it by 100, okay? So on this first problem here, it says an investment of $1,000 earns an annual interest rate. So we're going to say A is equal to here. We're going to go ahead and set up the problem first. That's going to be our 1,000. That's our P, right? Then we're going to take our E, and we're going to take it to the what power? So our interest rate is 7.6, so we're going to do 0.076 because we moved it 2 places to the left, 1, 2, right? So that's going to put a 0 right there, okay? And then we're going to multiply that times our 8, right? So that's going to be times 8. Now you can put this in the calculator just like this. So I'm going to show you guys how to do this on the TI-84. So we're going to take our 1,000, and then we're going to multiply that by second ln, that's our E, and we're going to multiply that by 0.076 times our 8, right? And then we're just going to click enter. So this is our answer, $1,836.75. Keeping in mind whatever that third digit is right there, we're always going to use that to either leave the number if it's a 4 or below, or round it up if it's a 5 or above, okay? So I'm going to show you guys how to do this in Desmos too. So again, we could go 1,000 here, and then we can type in our E, and then take that to the power of, again, our 0.076 times, oops, we better go back up there. Another one of those little tricks, y'all. So better put this in parentheses, okay? So we're going to put it in parentheses. I'm just going to go back over here, and I'm going to do 0.076 times my 8, right? Close my parentheses. See if I can get rid of that. Times right there by deleting it. Yep, there we go. Same answer. See, 1836.74. There we go. So obviously our amount is equal to 1,000. Remember, this is money. $836.75. Okay. So go ahead and do the U-try now using the same process. Come back to me when you're done. So here we go again. A is equal to, this time we have 2,000 as our principal. And we're going to do E. And this time our rate of interest is going to be 0.09. And we're going to multiply that times our 12. So go ahead and put this in the calculator as we did before. And our amount is going to be equal to, this time, $5,889.36. Okay. All right, now we got a couple others that we want to do. So these are going to be a little more complicated. It says the natural logarithm can be used to solve for an unknown exponent in the continuously compounded formula. So what we're going to do is we're going to write this using our formula, but then we're going to use ln to solve for our missing number of years. So it says, how long does it take for an investment to triple? So this is really important, this triple right here, because it's going to tell us. So normally our formula is what? It's A is equal to PERT, right? So if we want to triple our initial amount, that would be this right here, right? The P. So what we're going to do is we're going to do 3 times P, and that's going to be equal to P and our E. And now what we're looking for is not our rate of interest. We have that, right? That's our R right there. So we're going to be 0.072, but we're going to actually this time look for our T, right? So that's what we're going to solve for here, T. So the very first thing we'll do then is divide both sides by P, because we have that on both sides, right? So that's going to leave us with 3 is equal to E to the 0.072 T power, right? So now how do we get rid of an E? We use an ln, right? So that's exactly what we're going to do here. So we're going to do the ln of 3 and the ln of E. So again, these two cancel each other out. And when you take the ln of E, you get 1.0986, and that's equal to 0.072 T. So then what would we do? We would divide both sides by 0.072, right? 0.072. So now this is going to tell us how long it takes us to get the money to triple, okay? So when we divide this 1.0986 by 0.072, I got 15.26. So t is equal to 15.26, and that would be years, okay? Okay? All right, let's see if you guys can do that with this next one over here. If I can get my mouse to move, which it's not wanting to right now, So, all right, hopefully you've come back to me. Now, the difference between this problem and the first one is we've got this word double, right? So double means we're going to do 2p is equal to p e. Our rate of interest is here. So we're going to do, it's 8.5%, so we're going to do 0.085, right? So this is going to be 0.085 times t, okay? So once again, we're going to divide both sides by p, right? So that's going to get rid of the p there. So this is going to be 2 is equal to e to the 0.085 t power. How do we get rid of the e? With the ln, right? So once again, we're going to take ln of both sides. So when we take the ln of 2, we get 0.6931. And this is going to be 0.085 because those two cancel each other out, t. So we're going to divide both sides by 0.085. Okay. And when we do that, it's telling us again how long it takes us to double our money. And this time when it's being compounded continuously at 8.5%. So this time I got 8.15 years, okay? All right. So this last two problems that we're going to do today are using logarithms to solve for time, okay? So a city population, which was initially 15,500, has been dropping 3% a year. So we're going to write an exponential function and graph the function. And when we're going to find out when would the population be below 8,000. Okay, so now you can see this on a graph, but we can also solve for this. So I'm going to show you guys how to do this. Okay, so here, if you remember, our amount is equal to p times 1 minus r. It's going to be minus because it says it's dropping our rate and then our time, right? So what we're going to do is we're just going to populate this. So this time it says we're looking for 8,000. That would be our final amount, right? That's equal to our starting amount, which was 15,500. And that's going to be 1 minus 0.03 in t. So we're going to solve for t here, okay? So this isn't going to be an exponential, and we're going to use a log to solve it, okay? So what we want to do is first we're going to divide both sides by 15,500, right? Okay. So when we do that, we get 0.5161 here, and that's equal to, and if we simplify what's in the parentheses, we're going to get 0.97, right? And that's to the t power. So what do you think we're going to do? We're going to take this exponential and we're going to turn it into a log, right? So we're going to take log of a base 0.97, and we're going to take this value that's over on the left, 0.5161, and that's going to be equal to t. So this is how we use logs and exponentials moving back and forth to solve for things that are unknown, okay? So if you remember, we're going to use the change of base formula. So we're going to take what's the big number on top, the log of 0.5161, and we're going to divide it by the log of what the base is, 0.97. And when we do that, we get 21.71 years, okay? All right, I'd like you guys to try this on the problem over here on the right, and then we'll talk about the answer, okay? So this says the Pacific leatherback turtle population is decreasing at a rate of 5.6% a year. In 2021, there will be 25,000 at a current rate of decrease. What year will there be 2,500 left? Okay, so our final amount is going to be 2,500, right? That's equal to 25,000. And we're going to do 1 minus, again, the 0.056. And then we're looking for that t, right? So actually, we're going to look at the year, but we'll talk about that in a minute, okay? So we're going to divide both sides by 25,000, sorry. Okay, so this is going to be 0.1 is equal to, and when we do that 1 minus 0.056, that's going to be 0.944, right, to the t power. Okay, so here again, we're going to write this as a log. So it's going to be log base 0.944 of 0.1, that equals t. So we're going to use our change of base formula again, and we're going to say the log of 0.1 divided by the log of 0.944. So when we put that into our lovely little calculator, we get that it is 39.96 years. So that's about 40 years, right? So if we take our initial year here, 2021, and we add 40 years to it, that means in the year 2061, that's when we can expect the Pacific leatherback turtle population to be, wow, it's going really slow, y'all. 2061 is when we can expect that population to be at 2,500. Now, in problems like this, if it's asking you, like, when would I get at a certain, say we had an interest rate, and it was asking you when would I get at this much money, how many years, if it was, again, increasing, then we would just do it being a plus here, right? Y'all got that? That would be the only difference between the way we would do these problems. You'd have a plus here instead of a minus, okay?